This problem says that if you're given dy dx equals 1 minus y, and the initial condition being f of 1 equals 0, then use Euler's method with two equal steps to approximate f of 0. So Euler's method is pretty much just a fancy way of saying a series of tangent lines. So to find what delta x equals, which is where the two equal steps comes into play, you just set up delta x equals 0 minus 1, which is where you're wanting to end up from where you started, divided by 2 because of the two equal steps. So then that simplifies down to delta x equals negative 1/2 or negative 0.5. And then you use this little table to do the rest of the problem. So it tells us that our initial x value is 1, and the initial y value is 0. Then our slope is dy dx, so 1 minus y, which is 1 minus 0, which equals 1. And the tangent line is y equals 1 times x minus 1 plus 0 in point slope form. And then x plus delta x, so delta x is the change in x, so 1 plus negative 0.5, which gives 0.5. And then you plug all this into the y value, into the tangent line to see what the y value is. Which gives you negative 0.5. And then the new coordinates are 0.5 and negative 0.5. Here are our new x and y. And then we do this over again. So the slope, again, you plug it into the 1 minus y, so you have 1 minus negative 0.5 or 1 plus 0.5. And then the tangent line, you plug into point slope form, everything that we have so far. And then x plus delta x is 0.5 plus negative 0.5 or minus 0.5, which gives you 0. And then the new y value, after plugging all of this into the tangent line, is negative 1.25. So then your new coordinates are 0, negative 1.25. And that's your answer, is just negative 1.25. This problem says that a penny is thrown downward from a 200-foot tall building with an initial velocity of 40 feet per second. When does the penny hit the ground? So this problem gives us quite a few initial conditions, and these initial conditions are s of 0 equals 200 feet, v of 0 equals negative 40 feet per second, and a of t equals negative 32 feet per second squared. And that a of t is known because it is acceleration due to gravity. And then the reason why 40 is negative is because it is being thrown downward. So to start off with, we know that a of t, you can rewrite that as dv dt. So that's equal to 32, and then we integrate that, which gives us negative 32t plus c. And then you plug in the initial condition, which ends up giving you v of t equals negative 32t minus 40. And then we know that dv dt is just another way of saying, v of t is another way of saying ds dt. So ds dt equals negative 32t minus 40. Then we integrate that, which gives us s of t equals negative 16t squared minus 40t plus c. And then in order to find that c, we plug in the initial condition for s of 0, which gives us s of t equals negative 16t squared minus 40t plus 200. The problem asks us, when does the penny hit the ground? So that's asking when is s of t equal to 0. So in order to do that, we have to factor, and this is a really long one to factor. So what I found was the easiest was if we could pull out this negative 8 as a GCF, and then you were left with 2t squared plus 5t minus 25. And then I used Alabama method, which is another form of bridge method, to get t squared plus 5t minus 50 on the inside. And then I factored that, so I got negative 8 times t minus 5 times t plus 10 equal to 0. And since I multiplied that 2 in there, I have to divide it back out. So that's why you have negative 8 times 2t minus 5 times t plus 5. And you have to set that equal to 0. Whenever you set that equal to 0, 2t minus 5 gives you negative, no, sorry, that should be positive 2.5. And you should have negative 5 there. Let's see, let me fix that up here real quick. Just put a little. Okay. So that's positive 2.5 seconds. And this negative 5, because we're talking about time, there is no such thing as negative time, so that is not in the domain. So 2.5 seconds is the answer.